All right, so I had somebody ask about the first problem here on the Chapter 7 review, solving this equation right here. And it may not look like it at first, but this is actually a quadratic equation. So if you rewrite it, remembering that 4 is equal to 2 squared, so we can write it as 2 squared to the x minus 1 minus 3 times 2 to the x plus 8 equals 0. Now, when you have a power raised to a power, you can multiply them. So I have 2 to the 2x minus 2 minus 3 times 2 to the x plus 8 equals 0. And then you can split that to be 2 to the 2x over 2 squared, because a negative power tells you to divide. Writing the rest of this junk down. And then I'm going to make it into a monic quadratic. So multiply everything by 2 squared. Multiply everything by 4. So you have 2 to the 2x, 4 times 3, so 12, times 2 to the x, 4 times 8 is 32, 4 times 0 is 0. 2 to the 2x is 2 to the x squared. So we're trying to factor this or use the quadratic formula. When I look at 32, I think of 8 times 4, and 8 and 4 add up to 12. So you can factor this down to 2 to the x minus 4, 2 to the x minus 8. And that's almost there now because, 4 times 8 is 32, and 4 plus 8 makes 12. So now you use the zero product property to split it up into two different equations. 2 to the x minus 4 equals 0, or 2 to the x minus 8 equals 0. You can solve these using logarithms and taking the log base 2 of both sides. Move the 4 to the other side. So you have 2 to the x equals 4 and do log base 2. Or by inspection, x is equal to 2 because 2 squared is 4. And then similarly, when you have here 2 to the x equals 8, you can determine that x is equal to 3. And those are your two solutions. If you plug them back into the original equation, everything will work out very nicely. So that's it for problem 1a. I'm going to clear the screen in just a second and do problem 1b. All right, so problem B, probably a quadratic again, disguised, it doesn't look like it. Let's try it. So I don't like this fraction, so I'm going to multiply everything times 5 to the x minus 1. So I have 2 times 5 to the x times 5 to the x minus 1 minus 9 times 5 to the x minus 1 is equal to 1. Okay, when you multiply two exponents, what do? You add the powers there. So we have 2 times 5 to the 2x minus 1 minus 9 times 5 to the x minus 1. I'm going to go ahead and move the 1 over here as well. Minus 1 equals 0. Similar to what I did in part A, the negative 1 as an exponent is dividing by 5. So I have 2 times 5 to the 2x over 5 minus 9 times 5 to the x over 5, because we have another minus 1. Then let's multiply everything times 5. And if you multiply everything times 5, you have 2 times 5 to the 2x minus 9 times 5 to the x minus 1. Minus 5 equals 0, because I multiplied by 5. So, and then we can factor this to be 2 times 5 to the x. And then I know I have a 5 and a 1 in some order. Let me think about that. 5 to the x. I know I want to go times 5 over here because 2 times 5 makes 10. So I'll make that a negative. So it's a negative 10. And here I can do a plus 1 so that I've factored it. And that's all equal to 0. Now I can split it up with the zero product property. I love that leaf blower in the background right now. So we have 2 times 5 to the x plus 1 equals 0, or 5 to the x minus 5 equals 0. The first one has no solutions because the plus 1 is your horizontal asymptote. It will never reach the y-axis. The second one has a solution of x equals 1, and that should be your only solution in this particular problem. All right, that's it for this video. Keep asking for more. Thank you.